Let's move on to the concept of weighted average. Very important concept and very frequently asked. Weighted average is nothing but average of averages. So when objects being added have different proportion, the concept of weighted average is used. For example, if somebody asks you to calculate the combined average marks of both the sections of class 10, section A and B, when they have 60% and 70% average marks respectively. Okay, so I have section A, section B. This section has 60% marks. This percent has 70% marks. So these are the averages, and I'm supposed to calculate the average of these averages. And 60 and 70, if you look at it and you say the answer will be 65, this will be a wrong answer, because this answer will depend on the number of students in section A and B. Unless you know the number of students, you will not be able to solve this. Let's say the number of students are 10 and 20, just to understand this. So then what you'll do is, your method is, now these 10 and 20 will be called the weights. Okay, so if n1, n2, n3 are the weights attached to the values or the averages x1, x2, x3, then the weighted average, this is how it is calculated. You multiply the weight with the value and then add all of them. You divide by the total sum of all the weights, and that will give you the total average. So what I'll do here is, my average will be 10 into 60%. So 10 into 60 plus 20 into 70 upon 10 plus 20, which will give me 2000 upon 30, which will be 66.67. So this will be the answer, not this. Okay, so either I should know the weight, or there's one more thing. If I do not know the weight, but I know the ratio, that is also good enough. So if I know that the ratio of students between section A and B is 1:2, that will also serve my purpose, because if you do the same calculation, you will now, so let's assume the students to be 1x and 2x. So it will be 1x into 60 plus 2x into 70 upon 1x plus 2x. So that will give you 60x plus 140x, 200x upon 3x, which is same as 200 by 3, which is same as 66.67%. Okay, so that's how you get your weighted average. Couple of important things here. Section A and section B, the average is 60% and 70%. Okay. The final average or the weighted average will lie between 60 and 70. It can be 60% only if number of students in section B is 0, and it can be 70% only if number of students in section A is 0. Otherwise, it will never be 60 or 70. It will be somewhere in between. Okay. If the students are equal in both, and it's very similar to a weighing balance, and understand this carefully, if the number of students are equal in both, they both will pull the average to their side with equal strength, and the average will rest in between, right? Because students are same, they are pulling with the same effort, so the average will be in between. If the students of A are more, A has more students, they will pull the average towards themselves, and the average will be between 60 and 65. If the students in B are more, they will pull the average towards themselves, and the average will be between 65 and 70. Okay, so understand this, very, very important. And this concept we are going to use in mixtures and allegations also, that whichever weight is more or whichever group is more powerful, they are the ones who are going to pull the average towards themselves, and the average will be between that value and the middle value. Okay, simple concept. Great. Let's do some questions on this, and you'll see that questions on this can be fairly complicated. So we have this question, very interesting question, and this again is a CAT question of CAT 23. So the average mark of students in section A and B are 32 and 60 respectively. So these are the marks, and then we have the students. So students in section A is 10 less than that in section B. So let's say this is X. So this is X minus 10. Okay. if the average marks of all the students across both the sections combined is an integer. So what will be that average? You have to multiply weight by the value. So x minus 10 into 32 plus x into 60 upon x minus 10 plus x. This is what you get, which is you have 60x. This is, yeah. So you have 32x minus 320 plus 60x upon 2x minus 10. 32 and 60 will get combined to give you 92x. And if you see, everything is a multiple of 2. So let's reduce this to 46x minus 160 upon x minus 5. Okay, this is an integer. Okay, let's do a bit more. Denominator is x minus 5. Can I have my numerator in terms of x minus 5? If I write it in terms of x minus 5 and I multiply this 46, you'll have 46x minus 230. And here is 160, so I should have plus 70. This is, I can write it like this also. So this will change to 46 plus 70 upon x minus 5. Now for this to be an integer, this should be an integer. Okay, so we have arrived at a very important part, that 70 upon x minus 5 should be an integer. First part. And also x minus 10 should be a positive value. That means x has to be greater than or equal to 11, right? Because section A will have at least one student. So x cannot be less than 11. Now, so x greater than 11, what value will give you an integer? So if you see, if I take x as 12, okay, then you will get 70 upon 12 minus 5, which is 7. 70 upon 7 is 10. So x is 12 is the smallest possible value because x had to be greater than 11. Okay, what is the largest possible value of x? Obviously, for 70 upon x minus 5 to be an integer, x cannot be more than 75. If it is 75, then you can see that your denominator will be 70 upon 75 minus 5, which will be 70 upon 70, which will be 1. So the highest possible value of x is 75. In either case, the number of students in section A is x minus 10, x minus 10, that means 2 and 65. Right? So minimum students in section A is 2, maximum students in section A is 65, the difference is 63. Okay, so the difference between the maximum and minimum possible number of students in section A is 63. You can see a very simple question, but because you have difference of minimum, maximum, multiple values possible, this question becomes slightly difficult, but very easily it can be solved if you go step by step. Okay, good. Okay, now this question came in CAT last year, CAT 23. This was in LRDI set. It was not in Quant, but because the concept that it uses is of average and weighted average, I thought it makes sense to take this up here itself. And this actually gives you 5 questions. So imagine that in that CAT paper, you had, I think, one more question in Quant on average, and you had 5 questions here. So that gives you 6 questions. CAT total has 66 questions. 6 out of 66 is 1 by 11, which is almost 10% of the paper was average. So that's how important this concept can be. Okay, so let's do this question. And remember, this is 5 questions. So even if you spend a bit of time on this set, is completely worth it, because finally you are going to get 5 answers. Okay, so there are only 3 female students, A, K, and R. Only 3 male students, B, M, and S in a course. The course has 2 evaluation components, a project and a test. The aggregate score in the course is a weighted average, so weighted average of the 2 components, with the weights being positive and adding to 1. So what does it mean? Your project and your test. This weight can be A, this weight can be A1 minus A. Okay, because finally they should add to 1. The projects are done in groups of 2, with each group consisting of a female and a male student. Both the students obtain the same score in the project, and we have following additional data. Okay, so let's write down, let's make a small table. Where I have the project and the test, and I have the 6 students. First we have the 3 girls, A, K and R. Then we have the 3 boys, B, M, S. B, M and S. Okay. And remember, each project, each pair is a boy and a girl. Okay. Also the weight for this is A. The weight for this is 1 minus A. Okay. The minimum, maximum and average of both the project and the test were identical. They were 40, 80 and 60. Okay. So minimum for both is 40. Average for both is 60. And maximum for both is 80. And because you know the average, you also know the total will be into 6. So it will be 360 and 360. Okay, out of this 360, I already know 2 values. Minimum and maximum to someone will have to achieve. Average you may achieve, you may not achieve, but minimum maximum you'll have to achieve. So one score is 40, one score is 80, and average score is 60. Okay. The test scores of the students were all in multiples of 10. 4 of them were distinct, and the remaining 2 were equal to the average test scores. Okay. So I already knew there is a 40. I already knew there is a 80. Now I also know that 2 of them are 60-60. So I know 4 values. Okay. And the remaining 2 have to be distinct. How much this adds to? If you add this, 80 plus 40 is 120 plus 120, 240. Total is 360. That means 2 other values, let's say x and y, which I do not know, x plus y, should be equal to 120, and they have to be distinct. They have to be more than 40 because 40 is the least. They have to be less than 80 because 80 is the highest, and they have to be multiples of 10. The only values that fit are 50 and 70. Okay, so you know all the 6 scores. So these scores are 40 in the test. These scores are 40, 50, 60, 60, 70 and 80. Okay. Then Amla's score in the project was double that of Kohli. So Amla's score in the project was double that of Kohli. Now if you see, here also minimum maximum is 40 and 80, and that is the only value that can be double, right? Because anything more than minimum, you can't have a double, because more than 40, 80 is the highest. So that obviously tells you that Amla's score in the project was 80 and Kohli was 40. Very simple. Okay, but Kohli scored 20 more than Amla in the test. So Amla scored, let's say, x here. Kohli scored x plus 20. And there can be multiple combinations of this, so let's leave it here. Yet Amla had the highest aggregate score. Amla had the highest aggregate score. Okay. Shyamal scored the second highest in the test. In the test, the second highest is 70, so Shyamal scored 70. Okay. He scored 2 more than Kohli, but 2 less than Amla in the aggregate. So 2 more than Kohli and 2 less than Amla. Okay, in the aggregate. Biman scored the second lowest in the test. Second lowest is 50. And lowest in the aggregate. So aggregate is lowest. He's rank 6. Okay. Matthew scored more than Rini in the project, but less than her in the test. Matthew scored more than Rini in the project. Matthew scored more than Rini in the project. That means they were in different teams. Okay, so one thing that tells us is Matthew and Rini, they were not a pair. Okay, so this we'll use slightly later. So right now, let's look at what are the possible pairs. Matthew and Rini are not a pair. Okay, so and a male has to be paired with a female. So Amla can pair with whom? And remember, whosoever Amla pairs with will get the same project score. Amla got a project score of 80. So if you see, very unlikely that A will pair with B, because B has ranked 6th overall and A has the highest score 80. Okay. With M is possible. With S in fact has scored just slightly less than Amla, A -2. So it's possible that A and S may be a pair. Okay, we're not sure yet, but A and S may be a pair, right? Okay. Then we have, so A and S if we take, let's focus on K. K has scored 40, which is the least. Okay, and B has already got the worst rank. So chances are very high that K has paired here. Okay, because that will give B a very, very low aggregate score. Okay, so let's pair K with B. Okay, then we are trying if it works out good, otherwise we look at some other combination. So K with B we have paired. R does not pair with M, so R should pair with S. That means, so let's pair R with S and let's pair A then with M. Let's look at these pairs. So then that means this should be 80. K has 40 and K has paired with B, which is fine. R has paired with S. So 80, 80, 40, 40. So you can see that this is 80, 40, 80, 40 is again 120, 120. So in fact, the remaining two has to be 60, 60, right? Because it has to be equal and it should add up. So this we'll have to take as 60, 60. Okay, because the total is 360. Okay, so this is fine. We are just assuming this to be, because that is what logic says. If it's wrong, then K we had paired with B, we'll pair K with someone else and proceed. But let's assume for the time being that this is correct. Now A has scored X, but A is not, and A is still the highest. So of course X should not be very low and K should be X plus 20. So that means at most X will be 60, right? Because K can be 80. So let's give 60 to her because she's still the highest side. I don't want to give her too low. So 60 here, 80 here. Okay, so 60 goes, 80 goes, 50 goes, 70 goes. Okay, now I have a 40 and a 60 left. Okay, then this data. Matthew scored more than Rini in the project but less than her in the test. So Matthew scored less than Rini in the test. So Rini will score 60 and Matthew will score 40. Let's say this is the logic. Okay, now the real test comes here. That S has to score 2 less than A. Okay, so the score of A would be, and remember now comes the concept of weightage. So 80A plus 60 into 1 minus A. This is A score, and A score minus 2 should be S score, which is 60A plus 70 into 1 minus A. You multiply with the weightage, right? Okay, so what does this give us? 80A plus 60 minus 60A minus 2 is 60A plus 70 minus 70A. So let's look at all A's together. 80A minus 60A is 20A. 20A plus 70A is 90A. 90 minus 60 is 30A. So 30A is equal to 70 minus 60, 10. 10 plus 2, 12. That means A is equal to 0.4. That means it has a 40% weightage. So this is equal to 0.4 and this is equal, minus A obviously will be 0.6. If I use this weightage, so seems to be correct because this condition gets satisfied. Now it should satisfy this also, and that will prove that my answer is right. So let's calculate now the weighted score for everyone. So the project marks has to be multiplied with 0.4 and the test mark has to be multiplied with 0.6. Okay, so 80 into 0.4 is 32, 60 into 0.6 is 36, 32 plus 36 will give 68. So her score is 68. For K, 40 into 0.4 is 16, 80 into 0.6 is 48, 48, 58, 64, which is fine because Amla has to have the highest. 60 into 0.4 is 24 plus 36 is 60. Then 40 into 0.4 is 16, 16 plus 30 is 46. B should have the lowest score, which is so far. 80 into 4 is 32, 32 plus 24 is 56. And S is 16 to 24 plus 42, 42, 52, 66. So S has 2 less than Amla, and does he have 2 more than K? Yes, K has 64 and he has 66. So these are your all answers. And in fact, it has not taken us much time because now you'll answer 5 questions basis this. So let's see the questions quickly. The first question, what was the weight of the test component? Sorry, first question, what was Rini's score in the project? So Rini's score in the project was how much? In the project is 60. So the answer is 60. What was the score of the test component? Test score was 0.6, right? Project was 0.4, test was 0.6. What was the maximum aggregate score obtained by the student? 68, which Amla got. So you can see after this, there is no effort in answering the questions. What was Matthew's score in the test? Matthew's score in the test was 40. So he got a score of 40. And which of the following pairs of students were part of the same project? A and B, K and M. A and B, no. K and M, no. A has been paired with whom? A and M is a pair. K and B is a pair. And R and S is a pair. AM, KB, RS. AM, KB, RS, nothing. So neither one nor two. That is your answer for all 5 questions. So in fact, for 5 questions, this is not bad at all. Okay. Okay, so very good, nice question. 5 questions you get as part of this, so you can see how important average can be. Let's move on to the next question. This again is a nice question on the concept of weighted average. So 3 maths classes X, Y, Z take an algebra test. So we have X, we have Y, we have Z. The average scores are 83, 76 and 85. Average score of X, Y together is 79 and Y, Z together is 81. What is the average of all the 3? So we have first average, we have second average. Now we want to know the final average. Okay, this is a great question which explains the concept of the weights. And this diagonals that I've drawn, there's a diagonal method also to calculate, which we will discuss during alligations. Okay, but one thing you must notice that X and Y, if you look at 83 and 76, the average that I'm getting is 79. Whereas 83 and 76, if you see the difference is 7, half is 3.5. So 79.5 should have been the average. But the average is 79 this side. That means this class has a higher strength. Okay. You can also look at what value are you getting. So I'm actually getting 79. If you do now 79 minus 76, the difference is 3. That you can write here, and 83 minus 79, the difference is 4, you can write here. So actually the ratio of the students is 3:4. This is how we do this in alligations, where you directly find the ratio. Okay, but if we want to use the weights, let's use the weights and let's use a formula. So 83x plus 76y upon x plus y is equal to 79. That is what your equation will be. So 79x plus 79y is equal to 83x plus 76y, or 79 9y minus 73y is equal to 4x, or x upon y is equal to x upon y is equal to 3 upon 4. So that is what you get. Same thing what we had got here. How did we get this? Just remember that when you have this, you forget 79 minus 76. When you subtract, and does not matter the value is positive or negative, the difference you write on the other side. Similarly, 79 minus 83, when you subtract this difference, you write on the other side. That's all. Okay, so you get 3:4. Similarly, 76, 85, I am getting 81. So 81 minus 85 is 4. 76 minus 81 is 5. So this is 4:5. It is already 3:4. So I don't even have to combine the ratios. It is 3:4:5. Okay, so now the average of all the three classes together, now it becomes simple. 83 into 3 plus 76 into 4 plus 85 into 5. I told you that the ratio is good enough. You don't need to have the exact number of students. This should be my answer. So 83 into 3 is how much? 249. 76 into 4 is how much? 70 into 4 is 280, and 24, so 304. And 85 into 5 is 425 upon 12. This will give me 9, 13, 13, 18, 1 carry, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 9 upon 12. This, if I divide, you will have 8 times 96, then 18, so 1.5. 81.5 would be your final answer for this question. So this is a classic example of a weighted average concept question. Okay, great. Let's move forward.